Alright, in this video we'll take up another example based on Newton's laws, and let's try to do that. So the question is, suppose that you have a trolley here. The trolley has a mass of let's say 15 kilograms, and this trolley is attached to a pulley, and you have a rope here, and there's a person in the trolley which is pulling this rope downwards with some force F. Certain things are given to you, that the pulley is massless, the rope is also massless. The rope is not extensible, so that means it doesn't stretch. Rope is also massless. Why we'll need this, we will get to know when we write equations. Now let's try to solve this thing. You can assume the mass of the man to be 65 kilograms. So we have a trolley which is 15 kilograms and the mass of the man is 65 kilograms. We need to find out what should be the minimum force, or what should be the force by which this man and the trolley can remain at rest. That is, the whole system does not move. In that case, what should be the force applied by the man on the rope? So let's try to identify this. First of all, we need to draw the free body diagrams. That is what we need to do. So let's do that. We have this trolley. There's a tension which is acting upwards, because away from the object we have to take the direction of tension. Then because there was a person standing in it, now there is no person, but that person will be exerting some force, certain amount of force on the floor of this trolley. So let's call that to be N. So these are the only forces, and one is 15g, the weight of the trolley itself, which is acting downwards. So these are the only forces which are acting on the trolley. Now let's try to draw the free body diagram of the man. The man is pulling the rope down with the force F. The rope should also do the same. So the rope has a tension T, and that tension equals the force F. Why we can say this? We can say this because the rope is massless. I hope you get this. We can even prove this thing. Let's take the tension to be T and the weight to be 65g, which is acting downwards. There is a reaction as well from the floor of the trolley upwards, and that must be N. Now for the rope, if we draw the free body diagram of the rope, rope has a tension acting upwards and a force F acting downwards, but there is no mass of this rope. The rope is massless. So that should mean that F, or T minus F, equals 0, because there is no mass, or tension equals the force F. So that's why I said that we can even prove this thing, and this is only because the rope is massless. Had the rope not been massless, tension would not be equal to force. You will have to do that from equations then. So T equals F here. Here as well, T equals F, because the tension in the same string will remain same everywhere. You cannot change that. Now let's try to write the equations for this. For the trolley, we will have, assuming that it's remaining stationary, we will have T minus N minus 15G equals 0. Because tension is acting upwards, N is acting downwards. This is a reaction from the man. 15G is the weight of the trolley. It is also acting downwards. So all the forces upwards minus all the forces downwards equals 0, because the trolley is not going anywhere. It's at rest. So T equals N plus 15G. But we know T is F, so we can write this as F. F equals N plus 15G. Same way, if we write the free body diagram, or from the free body diagram the equation of motion for the man, we will have T plus N, because N is now acting upwards, minus 65G downwards equals 0. All the forces upwards minus all the forces downwards equals 0. So we have T plus N minus 65G equals 0. This was trolley, and this is man. So first equation. So from here we can say that F plus N equals 65G. This is our second equation. Now we need to find F, not N. So what we can do is, we can substitute the value of N as 65G minus N in the first equation. So we will have F equals 65G, this would be F, 65G minus F plus 15G. So from here we'll have F equals, this would be 80G divided by 2, or 40G. G is the acceleration due to gravity. I hope you understand this. First of all, we need to identify how the things are going on, what are the forces. We have to find out whether the things are moving. If they are moving, they are moving upwards, or they are moving downwards, to the left or to the right. And then we write the equations of motion separately for the horizontal and separately for the vertical. In this case, everything was in vertical, so that's why we wrote everything in vertical. I hope you understand this question, and we'll continue to have certain more questions in our other videos. So better check them out, and thanks for watching.